Problem number 100. Let M equals, we have a matrix which is 1, 1 plus I, 2I, 9, 1 minus I, 3, 4, 7 minus I, minus 2I, 4, 5I, 9, 7 plus I, minus I, 7. Then we have four options. Option A has only real eigenvalues. Option B, M has only imaginary eigenvalues. Option C, all eigenvalues of M are 0. And option D, none of the above. This problem is completely based on Hermitian matrix. Hermitian matrix. We will take example of Hermitian matrix. Let us first define what is Hermitian matrix. It is a square matrix. Square matrix A. If we can denote A power theta or A, that is Aij is equal to Aj must be conjugate. This is conjugate all Ij. We can take example. Let us take matrix A, which will be 3, 6, and we have to take complex conjugate 1 minus 3i and conjugate of 1 minus 3i, which is 1 plus 3i. Now this becomes our matrix A. For Hermitian matrix, diagonal elements must be real for Hermitian matrix. Now this is our example. Now we come to our problem. In our problem we can see 5, 7, 3, 1. They all are real. Diagonal elements are real. For Hermitian matrix, diagonal elements must be real and rest of the element should be complex conjugate. 1 plus I, then this should be 1 minus I, and here 2I, then this should be minus 2I, and likewise 7 minus I, then this should be 7 plus I, and here we have I and here minus I. Finally we have a matrix whose principal diagonal elements is real and remaining entries are corresponding conjugate. In our problem, principal diagonal elements, which is A11, A22, A33 and A44, which is equal to 1, 2, 5 and 7. They all are real, and elements A12 and A21 elements are complex conjugate, which is given as 1 plus I and 1 minus I, and likewise A13 and A31 is 2i and minus 2i. They both are complex conjugate, and element A and element A24 and A42 is 7 minus I and 7 plus I. Element 34 and A43 element is I and its complex conjugate is minus I. Clearly we can see our matrix, our given matrix is Hermitian matrix, and if the matrix is Hermitian, then all the eigen values of Hermitian matrix are always real. I can say our final answer, finally option A correct.